So if you want to prove that the derivative of cosine x is equal to negative sine x, you'll first need to remember the limit definition of a derivative. And so if we let f of x equal cosine x, and we take the derivative of f of x, we will have that the derivative ddx of f of x is equal to the limit as delta x approaches 0 of the function evaluated at x plus delta x minus the function f of x divided by delta x. And so if we replace the function here with what we set it equal to, we said that our function f of x was equal to cosine of x, then we can plug x plus delta x into that function, cosine x, and we can replace f of x right here with cosine x. And so we'll have that this is equal to the limit as delta x approaches 0 of cosine of x plus delta x minus cosine of x. And that is still divided by delta x. And so then in order to solve this limit, the first thing that we're going to need to do is to rewrite this function right here, cosine of x plus delta x, by using one of our trigonometric identities, or more specifically, an addition identity for cosine. And the identity looks like this. We have that cosine of a plus b is equal to cosine of a times cosine of b minus sine of a times sine of b. And so if we use this identity for this function right here, where a and b are x and delta x, then we'll have that this is equal to the limit as delta x approaches 0 of cosine of x times cosine of delta x minus sine of x times sine of delta x. And then don't forget to subtract this cosine x here. That is also in the numerator. So we'll have minus cosine x. And that will still be divided by delta x. All right, and so then I'll clean up my work here, and we can move on to our next step. And so our next step is going to be to rearrange our terms in the numerator here, and that's going to allow us to see something else that we can do that will help us simplify this limit. And so what I'm going to do is move this first term to the end of our three terms, and then I'll show you why that is important. So we'll have that this is equal to the limit as delta x approaches 0 of negative sine x times sine of delta x minus cosine x, and then we're going to add that first term here of cosine x times cosine of delta x. And then we will still divide by delta x. And so what we can do here now is notice that these two terms have a common factor of negative cosine x that we can pull out. And so if we do that, we'll have that this is equal to the limit as delta x approaches 0 of negative sine x times sine of delta x minus cosine of x times, right, we pulled negative cosine x out of this first term here, so we're going to be left with 1. And then if we pull a negative cosine x out of this term, we're going to be left with negative cosine delta x. So we'll have minus cosine delta x. Right, so if we were to multiply this back through, we would get negative cosine x for this first term, and then these two negatives would become positive, and so we'd have cosine x times cosine of delta x, and it would be positive if we were to go back through and distribute that. All right, and so then this would still all be divided by delta x. And so if we clean up our work again, our next step is going to be to split up this fraction into two separate fractions, right? We can have this term divided by delta x minus this term divided by delta x. And so if we do that, and we rewrite this limit, we'll have that this is equal to the limit as delta x approaches 0 of negative sine x times sine of delta x divided by delta x minus cosine x times 1 minus cosine delta x divided by delta x. Right, so all we did was split up this fraction into two different fractions by separating our numerators and still having them divided by that denominator of delta x. And so then our next step is going to be to remember one of our properties of limits, and that is that if you have a limit of two terms being added or subtracted together, you can split that up into two separate limits. So we'll have the limit as delta x approaches 0 of this term, and then we'll subtract the limit as delta x approaches 0 of this term. And so this will be equal to the limit as delta x approaches 0 of negative sine x times sine of delta x divided by delta x. And then we will subtract the limit as delta x approaches 0 of cosine x times 1 minus cosine delta x divided by delta x. And so then if we clean up our work here, we can move on to our next step, and our next step is going to involve simplifying these limits a little bit more, right? And so notice that each of our limits is as delta x approaches 0, right? So that means that we aren't worried about any other variable other than delta x in terms of these limits. And so this negative sign of just x, or this cosine of x, are not necessary parts of these limits. They're technically constants, if you want to think about it like that, because they're not going to be affected by this delta x. So we can pull those two terms out like constant multiples. We can just pull them out to have them multiplied by the limit, and that will allow us to see something pretty unique about what is left over in our limits. And so we'll have that this is equal to negative sine x times the limit as delta x approaches 0 of sine of delta x divided by delta x, and then we will subtract cosine of x times the limit as delta x approaches 0 of 1 minus cosine of delta x divided by delta x. And so then, if you look at the limits that we are left with, do you recognize these limits at all? Well, if you don't, these two limits right here are two special limits for trigonometric functions. We know that the limit as x approaches 0 of sine x divided by x is equal to 1, and we know that the limit as x approaches 0 of 1 minus cosine x divided by x is equal to 0. And so even though these are limits of delta x, the variable delta x is also inside sine and in the denominator, and so it's the same limit but with a different variable, and so it's still going to have the same answer, right? You could switch out this variable with any variable. It could be y, it could be delta y, you could replace it with z. As long as they are all the same, this limit is still going to hold true. And that is the same for this limit right here, right? We have the limit as delta x approaches 0 of 1 minus cosine of delta x divided by delta x, which is the same limit as this limit right here, except it is defined with x. And so it doesn't matter that the variables are different, they are still the same limit. And so this limit will become 0, and this limit will become 1. And so we'll have that this is equal to negative sine x times 1 minus cosine x times 0. Right, and so then anything times 0 is 0, and so this whole term is eliminated, and so what we have is that this is just equal to negative sine x. And so then that's it. We have just proved that the derivative of cosine x is equal to negative sine x. And so now when you come across that derivative rule, that the derivative of cosine is equal to negative sine, you now know where that comes from. Alright, and so that's it for this video. If you have any questions, leave them in the comments. If you found this video to be helpful, feel free to check out my channel where I have some other math-related content, including many lessons and example videos for calculus. But this is all I have for now, so I will see you next time.